Hi everyone, my name is Geneva Archer and my partner is Camille Harrison, and our project is the daylight simulators for the KBIC fish hatchery. So an introduction into the fish hatchery is it was established in 1989 and it currently stocks lake trout, brook trout, and walleye. The purpose of the fish hatchery originally was to replenish what they were taking, but now it's a part of its mission is to mitigate the environmental issues with the spawning at Buffalo Reef. And currently, with natural issues such as the SNAP sand and economical issues such as COVID, the hatchery could really benefit from a shortened spawning season. It's currently at 4 months, but it should be half of that naturally. It's usually only 1 to 2. And there are two buildings with the fish hatchery, and you can see in the layout in Figure 1. In the upper left-hand corner, of the picture is the isolation building. And this has the egg incubation room in the upper left-hand corner of that building and the spawning room on the right. And in the lower right-hand building is the production building once the fish get bigger. So some areas for improvement. The fish have different lighting needs for the different stages of their lives. And so the different solutions are different for each of these rooms, the incubation room, the spawning room, and the production building. So for the spawning room, they already implemented really big bank windows to allow daylight to come in. So that already rises and sets pretty naturally. The only issue there is that is a human error component that I'll go over in a bit. So for the egg incubation room, the fish need as little light as possible. We're talking 0 to 1 lux. But the workers need light to see. And so often when the lights are flicked on or put too bright, then more fish die. And they'll see a spike in the mortality rates, even if somebody opens the door and a bunch of light floods in. So there's a lot of non-electrical solutions to that problem. And I'll go over those in a bit. For the spawning room, it's the same thing as the production building, where if somebody flicks the lights on, it shocks the fish, and the fish need time to recover before the workers can actually work with the fish at all. And this hinders the workday, and it's not healthy for the fish. So the solutions that we proposed are daylight simulators that focus on a lighting system that will rise and set with the sun. And so focusing on the production building, where there's only flicking on lights on and off and there's no big windows, they just have overhead fluorescent lights. We plan to implement these overhead LED lights that, like I said before, can rise and set with the sun. Some other solutions that we came up with were for low lighting navigation, because when workers need light to see, but if they turn the lights on, that's not healthy for the fish. And so we came up with some solutions for that as well. And for even in the egg incubation room or for further navigation, we got some glow-in-the-dark tape and paint and reflective light. So I'll move my little picture to the left side of the screen. And I'll talk about some results and conclusions. Oh, just kidding. I missed the center of the poster. Diagrams. So you can follow the life cycle of the brook trout through the fish hatchery. And like I mentioned before, they start out as little eggs in these crates in the incubation room. And as they get bigger, they turn into sac fry. As they get bigger, they turn into fingerlings. As they turn bigger, they turn into par. And that's when most of them are released, but some of them are kept for spawning. And then they obviously spawn more eggs, which gives the cycle of the brook trout again. On the bottom, it starts talking about Arduino programming, which we used for both the LED strip lights and the overhead LED panels. So for the LED strip lights, what we found out we could do with Arduino programming is get the lights to dim, and we were able to individually address them. So that means if I have a strip of lights, I can get every other or maybe every third LED to light up, but not the rest. And so this will be really helpful for the low lighting situations. And we also took lux measurements of each of the shades of each of the colors for each setting at the brightest it could be, so that we could compare each of the shades, and the KBIC can give us feedback on how it's being used. So if it's too bright or too dim, we can switch up the LEDs accordingly. For the overhead LED lights, for the big panels that we're planning to put into the production building, we went through a large process of trial and error and finally are on a good path, or so far we think. We were able to get them to dim using a handheld potentiometer. And from there, we built our own digital potentiometer through a series of resistors and adding in transistors. And with that, we were able to program the Arduino to, and the breadboard shown in the photos at the bottom of the diagram, to allow that to dim. And you can see the photo of the hand is moving a wire from one resistor to the next, which represents different dim settings. So adding the transistors will hopefully automate that signal independently. Adding an RTC, or a real-time module, allows the Arduino to connect to time in the real world. And so what that'll allow us to do is connect the time within the circuit of the LED panels to the time in the real world, so that when we want it to rise at a certain time and set at a certain time, it will be able to do so. And even with subtle differences between summer and winter, we'll be able to take into account the differences in the amount of light during those seasons. And so through trial and error, like we mentioned before, Ian Matson came up with a really great new circuit plan for the LED overhead lights for upcoming years to improve our current prototype that we've come up with. And the goals of the project changed a lot throughout the course of our 8-week program. After talking and communicating with the KBIC quite a lot, we were able to refine a lot of the questions they had and a lot of the goals they had to figure out what it is that they really want done. And I suspect that there will be a similar pattern in upcoming years of changing directions based off of what the goal is that we really want out of this project, considering every time we add in a new puzzle piece, like the real-time module, or in future years, it will be solar panels to lower energy costs and the amount of electricity going through the fish hatchery. As for community engagement, Camille and I always really loved interacting with the KBIC. We went to a lot of their cultural activities, such as the powwow, which was just astounding. And we did Garden for Heart every other Saturday. I found out I actually like weeding and harvesting the little strawberries and snap peas and snow peas. And we even planted apple trees and elderberry plants, and I'm rambling, but it was a lot of fun, and Camille and I always really loved that. And the engaging in these activities was really helpful because at the beginning of the project, we had some struggles with communication due to emails failing to go through. But being able to meet face-to-face, we were able to talk about meeting again and planning out events and moving forward with the project. And I was really happy to hear that when they first came up with this program, through learning a lot with our sessions on Wednesday with Dr. Ganu, we shouldn't assume things. And so when they were coming up with this program, instead of going to the KBIC saying, we can fix this, we can do this, this, and this, and we can help you in all these different ways, we should go to them saying, how can we help? And what is it that we can do for you? We want to help. We're here to listen. And that was really impactful for me to hear that. And I think that is part of what changed me as a person, is intelligence should not make you arrogant. And so through all of that, I just wanted to acknowledge the entire KBIC community, especially Valerie and Evelyn and David and Alan and Karina and everybody who worked with us at the fish hatchery personnel and more, because they truly made this an amazing experience. And I would also like to acknowledge Professor Middlebrook, who was our faculty mentor for this project, and Ian Matson, who is an excellent resource for us for electrical engineering, and the REU faculty and coordinators such as Dr. Rao and Professor Hati. And you can see I have my references listed in the lower right-hand corner. Okay. Have a nice day.